Mhm.
Pass by reference array plus 1 minus array.
Okay, so let's get started. So, are there any questions? So I posted a midterm 2 sample here, just like midterm 1 had, and a review. So here it just tells you what I'm going to test. I mentioned this last time. The topics may require the concepts that you've learned already, but I'm not going to explicitly test on like if statements, for loops, whatever. So it's going to explicitly test the stuff in here, but it's not going to be explicitly testing anything else. And the format's exactly the same as last time. Okay, any questions? So remind me to stop a little before the end of class because I have a handout for you. Okay, so what have we been talking about?
Arrays.
Arrays. So what is an array generally?
Consecutive addresses in memory that hold data.
Yeah, so it's just a big chunk of data which has a lot of individual elements. So we can store a lot of integers or really any type we want to create. So if we want to store a lot of student objects or anything really, we can use an array for that. So we've been talking about a whole bunch of stuff on arrays. So like how do you store things into an array? By using the square brackets. How do you iterate over the array? The two ways mainly are just to use a loop, a normal loop, or you can use a range-based for loop, which is superior in pretty much every way. We saw that there's no explicit bounds checking, whether you go past, whether you try to access an invalid index or not. So you have to be careful with that. Yeah, there are a couple of ways to initialize an array. We saw ways to copy one array to another. So if I have an array over here and a different array over here, and I want them to have the same contents, then I can just copy individual elements one by one into the same index in the other array. Checking equality. So the if statement up here checks if they have the same, they start at the same memory location. Whereas we usually want to know, do they have the same contents? So the way you do that is you just iterate through the array, look at index 0 of both arrays. If they're different, then they can't possibly be the same. Then march forward one position. If they're different, then they're not the same. If they are the same, keep going and go through the entire array. And if it's the same all the way through, they must be the same, assuming they have the same size. Then we talked about simple things that we could do with understanding data inside of an array, such as what is the sum of the elements in an array? What's the average? What's the largest? What's the smallest? Any kind of metric like that, we can use an array for. Or it's really simple to use an array with it. When to use an array is primarily when you have a situation where you have to store the values somewhere. If you're just iterating over the values once, say from the user, you probably don't need to store the values. So you probably don't need an array for that. But in some cases, like the ones you'll see in the handout, there are cases where you do need to store the values somewhere, such as the user enters a bunch of data. Now print all the contents in reverse order, starting from the last one that was entered and go back to the first one. You have to store the data for that one. So you have to understand when is it okay to use an array and when it's absolutely necessary. If you just want to know the sum or average or largest or smallest, you probably don't need an array for that. But sometimes you do for other problems. Okay, so we talked about this last time, something called a partially filled array. So as was noted by some of you, there are ways to figure out the size of an array, although that's a little disingenuous, as you'll see as one of the exercises in the handout. So let's just say that there really is no reliable way to get the exact size of an array. If we have, like, say, a 100-element array and we put 50 values in, then is there a way for the array to tell me, oh, you put in 50 values into this array? No, there's no way for it to tell us explicitly how many values we entered. It just knows there's 100 values stored. The other 50 that were not entered by us could be any value from what we have seen. So if you are working with something called a partially filled array, you need to maintain yourself how many values are really in this array. If we've entered 50 values, we need to maintain how many there are, 50. If we enter another one, then we need to increment that. So we have entered 51 now. If we remove, quote unquote, a value from the array, so that's not really what it does, but if we want to remove a value from the array, then we want to decrease the number of values in that array that we are considering. So when we get to vector, this issue will be eliminated completely, so we don't have to worry about this really. It's just if you're working with raw arrays, you may want to keep track of how many values are entered. Yeah.
Would you do that just with a counter? That
Yeah.
you would add in your loops, so every time it would see it, it would add one more?
Right, yeah. So the way that was suggested is if you're entering values, you can just have a counter that starts at 0, and then when you do a cin statement or you assign to the array somehow, you need to increment that. The only issue that might arise is what if the user somehow has access to which index is being addressed? So like the user could say, assign 42 to index 0. Then the next input is assign 79 to index 0. If we were a little naive in how we did this, then we will say we've entered 2 values into the array, whereas we've only entered 1, because we've only entered into 1 index. So there's a way around this, but you have to be a little bit careful with this. And so the workaround is, if you're curious, have an array of integers of the same length, and if the user enters a value into some index where that second array has value 0, then set it to be 1. The reason for this is if you assign to an index that's not been set to previously, then the value in this array that we just created will have a value of 0 if we initialize it correctly. Then if we assign a new value to a new index, then this value will become 1. But if we've already assigned to this index, then the value there is already 1, so I won't change the value there. And so how would I figure out how many values are entered in this array? Another way to phrase it is, how many indices have I assigned to? What I do is look at the second array, count the number of elements that are assigned to 1. And then that'll tell me how many indices have been assigned to 1. Whereas if we just did this naively, we may count the values incorrectly. So just be a little bit careful with that. Okay, so here's something that is becoming more and more popular. So think about objects for a second. So let's just think of student objects for a second. Then what you may want is to create an array of students so that each student has his or her own name, ID, GPA, whatever. So they have their own independent variables. So then for a student array, we will just have one student here, then the next place has another student, then another student, all the way through. Sounds simple. The issue actually comes with performance. So let's just say that we want to locate the student in the class who has the highest GPA, for instance. Then what happens? So I look at the first student. The only data that I look at is that GPA of that one student. I don't look at any of the other data associated with that student. Then I look at the next student for the GPA and nothing else. Then I look at the GPA of the next student and all the way through. So what happens is if I have say millions of students that I'm looking through, maybe for an application of some kind, maybe to provide funding, then what will happen is I'm going to trash performance because I'm only looking at one small piece of the student and not the entire student. And so when I'm trying to bring in that student object into the CPU to process, I'm only looking at one piece, whereas I'm bringing the entire student object into the CPU all at once. And so that will trash performance. If you're curious about why this is, it's kind of complicated, but if you look up the cache hierarchy, as it's called, then you can figure out why this is actually terrible for performance. So parallel arrays, what they do is they take these student objects and break them up into their respective components. So let's just say here, instead of having each student have his or her own name, average, and grade, let's say in this case, we're going to have 3 arrays right here. Let's just say of 5 students, where let's just look at index 0 of all of the arrays. Index 0 corresponds to one student. Index 1 corresponds to another student. Index 2 is another student. Index 3 and index 4 are all their own individual students. And so why is this better? Because if I'm just looking for the highest grade in this case, then all I need to do is look at this one grade array. Then if I look at each of the elements in turn of this grade array, then I'm not throwing any data away. I'm only looking at the data I need to. And so because of that, this is much better for performance. Why might this be a bad idea to use parallel arrays though? It's great for performance. Why might it be a bad idea?
Made a change to iSize, it makes a change to all 3.
Well, not exactly that. So the good thing is that the arrays are parallel in that each index across the arrays is one corresponding object, so I don't have to worry about that. But the issue is, what if I update one student? So maybe like one student graduated and now a new student comes along and takes up index 0. What do I have to do? I have to update all of the arrays simultaneously. I have to update the name, the average, and the grade across the arrays for this one student. Whereas if I just had one student object array, then I only need to make one update. And so here's another thing so you may think, okay, well, 1 against 3, that's not really a bad idea. Consider this. Suppose, for instance, that we needed to sort the names array. We haven't talked about sorting yet, but let's just say we had to sort the names array. What happens to the other 2 arrays? They don't sort in the same way. So if I change the name array, like I swap elements, for example, of the name array, the average and the grade arrays are left alone. And so now if I look at index 0, that might not be the same student. So if I'm going to have to do modifications to one array, I have to make the same modifications to the other 2. And that's a giant pain. So using parallel arrays has its pros and cons. It's great for performance, but it's terrible for maintaining them. So just be careful if you're going to be using parallel arrays. Okay, so in order to process them, it's pretty simple. So they all have the same size, which is great. So what you can do is so this would actually be a case where you do need the index, because I need to access the same index across the arrays. I can't use a range-based loop because that just gets the values out of one array, not the indices. So, and with just a value, I can't look up the same student in the other ones. So here I need the index. I can just print the name of the ith student, as well as the average of the same student, so the same index, and then the grade of the same student. So it's pretty simple to process, but it's hard to update. Yeah.
It wouldn't be too bad to update all three of them if you used it like in an object with a constructor, wouldn't it? Because you would just call the constructor that would just update the indices for all three at the same time.
Yeah. So you're right. Again, updating the values is not the issue. Updating the arrays is the issue. Meaning that if I'm going to be swapping elements of one array, I have to do the exact same for the other two. And you think, okay, well, 3 swaps versus 1, that's not a bad idea, not terrible. What if I add another feature? And so now I have to do more modifications. And so if I keep adding features or attributes of the student, now I have to make some more changes. Whereas if I just had a student object array, then I don't have that issue. So it really depends on what is important for your application. Is it performance or maintainability? So it really depends. But any questions on parallel arrays? Okay, so this right here, this thing called typedef, I almost should change this to more modern standards, and I'll tell you what the more modern way of doing this is. But this is really only here for historical reasons. So you'll see typedef all over the place, but it's not the right way to do what it's supposed to do. So what does it do? Typedef, all it does is rename something into something else. So if you want to take something that is a lot to type and then just give it a new name so that you could just use the new name, typedef does that. So if I want to change unsigned int to the term uint, so instead of having the type unsigned int, I can just write uint, which is much shorter. Then just do typedef, the thing you want to change, and then the last thing is the new name. So that's all typedef does. Nothing really interesting there.
Where would you do that?
So it's when would you do this? It's mainly when you have a really long name right here that you don't want to type over and over and over, and then make it a shorter. It's an alias.
Oh, I mean like where in?
Where? You can do this anywhere. So I can have typedef whatever at any point in the program, but it has the same scoping rules as everything else. So when you have it declared somewhere, you have to use it below where it is. So it has the same scoping rules. So you may be wondering, okay, typedef is fine. What about a more modern way? We've actually been using it. We've been using it this entire class. So it's actually the using keyword. So for instance, so I could say using using str equals string, like that. So instead of having to type string over and over and over, I can just type str like this. So the way you do it in the more modern way is say using str, or whatever you want to rename it to be, equals the thing that you want to have renamed. So string in this case. So, but look up here. It says using namespace std. I don't see an equal sign there. So what do you think that means?
Namespace would be like a upper hierarchy. Like iostream is in the brackets, like that would be a higher standard.
So,
Already defined one.
well, if we didn't include this, if we didn't put that, and I wanted to use a string, how would I use it? std : string, like this. So what does the using namespace std get you? Yeah. So I don't have to type std:::. So when there's no equals like this, it effectively just says drop that part. So you don't have to type that corresponding part. Whereas if I just said using namespace std, or maybe I can say using namespace standard equals std, then I could say standard string like this. So by not having the equals there, it effectively drops the std from the namespace that we would normally have to type like this. So instead of having to type std::, this drops the std from it. But we could rename it to something else if we wanted to. And this happens a lot. So I'm not sure how many of you have heard of this, but there's a library called Boost, which is basically an addendum to this C++ standard library. So it has a whole bunch of awesome features in it. But one of the issues is that there's a lot of namespaces in there. So it's like names boost : this library : this : this. And so it's a huge issue to type all that. So what you do is you can just say using most of the entire thing equals some small text, and then I can just do the last few if there are any, using the normal : So it's usually for when you have a long namespace of something to address some function or some value, and just rename it to something else to make it a lot easier so you don't have to type it. Yeah.
Can you do multiple namespaces? So like using namespace standard and using namespace boost? And
Yeah, so you can definitely do something like that. So if you have multiple spaces, you could do this, and I've talked about why this is a bad idea, but you can definitely do this. So I could even say using namespace b equals boost, for example, if we're working with the boost library. You don't have to know what the boost library is, but it's just another library which where people often using to shorten the names of how to address various things. But typedef does what it does the exact same thing. It's just that using is more modern. That's the only reason. So typedef is here for historical reasons only. Okay, yeah. So what you could do is, although I really don't advocate doing this, even with using, is that you can rename an array type as something else. So I could just say, instead of having declaring these high temps and low temps arrays to have 12 elements in them, I could just alias the type of 12 months as an array as a name itself, and then use that as the type of the arrays. So the reason why I don't like this is that, can you tell just from this line down here and nothing else, could you tell that they're arrays? Well, the name kind of implies it, but does it mean that it is? No. So then you have to actually look at the definition and say, oh yeah, it is an array here, because there's no square brackets telling us that it's an array. So that's why I don't really like doing this, but sometimes you actually see this, unfortunately. Okay, so don't worry about typedef other than what it does. So I won't ask you to actually use it because it doesn't occur that often. Okay. So we can pass array of values as arguments to functions. So if I want to print the ith score or pass it to this function, whatever it does, I can just say score of I. So I can just pass any value I want to a function, and if it lines up, in this case, the score array has to have what type? Yeah, it has to have integers, because if you look at the function right here, it says I take integers. And if we're passing some value to it, then we need to be able to pass an integer. So this has to be an integer array. But we can pass arrays, array values as arguments to functions. But sometimes you may want to pass the entire array over. So instead of just a specific element, we want to take the entire array over. So instead of having cluttering up our main function code with saying loop over the array and print the ith value, what we can just say is pass the entire array over to this function and have it do the work of printing the values. So in this case, like a show scores function could, so I don't know what this 5 is supposed to do, but okay, yeah, I know what it does. So you can just pass the entire array, and then what you do in the header and the prototype of the function is you say wherever you want the array, just put square brackets with nothing in them. And that's what you usually do. There's a different way of doing this exact thing, but if you want an arbitrary array, then just do it like this, square brackets with nothing in them. And in this case, because arrays don't have a way of figuring out how many elements there are, even though there is, but let's just assume there isn't, then here in the second argument, we're passing the number of elements in the array to help it along, because the function doesn't have access to the size variable we declared earlier in the other function. So we're just helpfully passing it along to the function. Okay. So I mentioned before that when you look at the array name itself, just the name, what is it? It's the memory address. So another word for that is what we have seen so far, a reference. So the array itself is a reference, but each individual element can be thought of as a reference variable, even though it technically isn't. Because if you think of like array of I, for example, can we set to array of I? Yeah, because we can always set to a variable here. Whereas if we just look at the value itself, it's just a value. It's not a reference. So arrays are kind of weird in this respect, but so I wouldn't worry about it too much. But if we pass the array over, they behave like references. So if we make a change in this function, it'll modify the original array because arrays themselves are references. So just be careful about that. If you don't want to modify it, the array in this function, what should you do? Make a copy is one way, but what's a better way? Const. And why is that better than just making a copy? It saves memory. But there's no functional difference between the two. Okay, any questions on arrays dealing with functions and whatnot? Okay, 2D arrays. So you can have arrays of arrays. Is your mind warped yet? You can have arrays of arrays. So here you can think of this as this first one right here is saying there are 4 elements, whatever they are, in this array. There are 4 elements. And each one of them has 3 elements. So each of these 4 elements is a length 3 array. So you can think of it as a 2-dimensional grid like this. So you can think of the first index as the row that we're looking at, either row 0, 1, 2, or 3, and the second one right here as the column index. So how many elements, if I have n elements right here and m elements right here, what is the number of elements in the entire 2D array? N times m, good. So, and this will be handled in exactly the same way as we have used arrays before, both setting and getting. So if I want to set exams of 0 of 0, then I just put on the left side exams of 0 equals 42 or whatever. So they do exactly the same thing. Yeah.
I had trouble incrementing, like to put information in. I couldn't figure out how to like increment, like row, column, like row, column, row.
Yeah.
row,
Okay.
column.
Good. I think we're gonna get to that. Yeah. So we're gonna get to that. So yeah. So you can access individual elements like this, no issue. You can initialize using an initialization list like this, although people don't typically do this. Yeah, and there are some notes here. It's not really that important, and I won't test it. But the key question is here, how do you access each element of a 2D array? So the idea is, well, we could access it in one of two ways. I can access it like one row at a time. So the first row, then the second row, third row, all the way through. Or I can access it one column at a time. Either way, I'm going to access all the elements in the array. It turns out row traversal is far faster than column traversal, so I might as well teach row traversal. So how do you actually do this? So let's do, in fact, I don't even need the using thing. So let's just make an integer array. And I'm going to put, how many rows do you want? 3. And how many columns? 3. Oh, you're not feeling ambitious. Okay, so let's see. What is the highest? I'm actually going to make a modification here because I want the number of rows and columns to be different. But there's nothing inherently wrong with the earlier idea. What is the highest row index that we can have? 2. So what I'm going to do is, if we're going to access it in row order, then I'm going to have 2 loops. So the outer loop is going to process one row at a time, and the inner loop is going to process the one row, but across the columns of that one row. If I wanted to do column traversal, doing 1 columns at a time, what would I have to change about that? So instead of having row traversal on the outside, what should I have instead? Column traversal, and then put the row traversal in the inner loop. So I'm going to have a for loop right here that starts at, what is the starting index? Always 0. It's always 0. And then row less than strictly, what in this case? Strictly 3. So yeah, so be careful about that. And then add 1 every time. Add 1 every time. So now in here, we're looking at the row of array. Technical term. So we're looking at a single row right here. Single row. Then now for this one single row, what are the columns that we should access of this one single row? 0 to 3. Could the columns that we're looking at depend on the row? Well, think about it. Each one of the row arrays right here has precisely how many elements? 4. So in fact, it doesn't matter which row we're looking at. We're still looking at the same columns, 0 through 3 inclusive. But if you wanted to only look at a certain number of elements depending on the row, then it'll matter. But all we're doing here is we're printing everything in the entire array. So we got to look at every column. So I'm going to have the columns start at what index? 0. And then the column strictly less than what in this case? 4. Good. So, and then col plus plus. I've actually made this mistake many times, so be careful. I made the mistake of doing this. Putting the row here. What'll happen? Will it ever get out of this loop?
No.
No, because when it's set to 0, this condition is always true. So be careful. So I've been burned by this. Don't worry. Even I make this type of silly mistake. So maybe let's think about how we want to print it. Maybe we want to print it like an array like this in a square grid. So let's just say that for each individual element of one row, we want to separate it by one space. So what should we do in here? Maybe I'll put the using namespace std thing. So what should I do in here? Well, first off, I want to print the element that I want to print, and then print a space. So what is the element that I want to print here?
The array row.
Of row?
And then column.
Of column. Good. So if I just stopped right here, and I just said array of row, what will this give me?
That would just give you.
Yeah, the address of the array where the row is stored. So, but if I want the actual element, I want to do call. I want to look at the call index of this row. And then we're going to print a space afterward. So there's one more thing we have to do, which is what? Right. So if I just did this, then I'm going to print the first row here. And then what's going to happen is the second row is still going to be on the same line, then the third row, then the fourth row, all on the same line. If I want each row on its own separate line, what should I do after I process the entire row, all of the columns? See out a new line. Yep, precisely. So let's compile this.
Would it be the same thing for the input data without the?
Yes. So if we want to input the data in row order, then you would do this exact same idea. So you would have the rows on the outside, the column for loop on the inside, and cin to array of row of call. And then that will input to that one particular place. So if I print out, we get exactly what we should expect. Yeah.
Isn't that putting the columns in the row spots? It's like.
No. So this is a good question. So you may think, okay, this 3 and 4 right here, what is the row? What is the column here? And it turns out it doesn't matter. So the computer doesn't actually store it like a 2D grid like this. It does it in a different way. So we're treating the 3 here as the rows. But I could equally treat the 4s as the rows by swapping the role of row and call here. So in fact, what I could do is just say, I'm going to print call of row, but the thing is now I need to, actually I need to process this differently. So I need to move this for loop down to here, oops, and then move this one back up to, let's see. Where is it? Here. And make it nicer. So here, I'm accessing all of the same elements, but I'm printing them in a different order. Oops, I messed up. Oops. Yeah, so now it prints the transpose of the matrix here. So yeah, so the 3 and 4, I can artificially treat one of them as the rows and one of them as the columns. It doesn't actually matter to the computer. Did I answer your question? Okay. Other questions? Okay. So we talked about that. I'm going to breeze through these because they're not really that important. Compared to what we're going to get to. You can have n-dimensional arrays. So I can have arrays with as many dimensions as I want. So instead of just 1 or 2, I can have 100 if I wanted to. It's a giant pain to deal with, but because you have to index into every single place of every single subarray, but I can do it if I wanted to. Yeah, so some notes here. It's not really that important. Okay. You can have arrays of objects like we have discussed before. So the array can be of any type that you want, including user-defined types like square. Okay, so now we have finally come to our Lord and Savior, standard vector. So this is probably my favorite part of all of C++ because it liberates us from the downfalls of arrays, but gives us the same power as arrays. So I don't think there's any use case where you should use a normal array versus a vector, because vector handles a whole bunch of things for you that you don't have to handle yourself, and it does exactly the same thing. So I can do the square bracket operator just like with arrays. So use vector in every place that you could possibly use it. Okay, and so one of the issues that we had before was, what if we wanted to figure out the number of elements in the array? Or we want to copy one array to another, or anything like that. So the intuitive idea behind vector is, let's override some of the operators to make them look like we want them to use them in the way that we expect. If I want to copy all of the elements of one vector into another, just do assignment. Whereas with arrays, did that work? Can I just assign one array name to another? No, because that's assigning the address of the array. Vector, it works fine. What if you want to add elements to a vector, but then the array gets too full? What do you do? With a normal array, what do you do? I have to make a completely new array and copy all the elements over, and then add the new element in there somewhere. Vector, it handles that all on the back end for us. We don't have to think about it, it just works. What if I wanted to, let's just say we have an array, and let's just say it really does have enough data to hold all the things we want to put into it, but we want to put one element at the front of the array, at index 0. What do I have to do with the existing elements? I have to shift them all forward. And we saw that was a giant pain to deal with because we had to go backwards through the array, and it was a giant mess. Vector handles that for us immediately. So should you use normal arrays versus vector? No. So yeah, just use vector at every possible place. So a vector is just an object wrapper. All it is just a wrapper for an array. That's all it is. So it's like we can make a class which just holds a single array as its data member, and that's it. Yeah, so this is kind of a red herring, even though we won't actually care about it. It says it has a flexible number of elements. If it holds an array, really does hold an array on the back end, does that array have a flexible number of elements? No. So this is one of the nice things of abstraction, abstracting away from the details. To us, when we look at array right here, when we look at vector, it looks like it has a flexible number of elements, even though it doesn't actually have a flexible number of elements. So that's one of the nice things of abstraction. It's defined in something called the standard template library, and we'll see what this template thing actually is. Yeah.
So on the back end, does vector hold multiple arrays and like hybridize the arrays?
We actually don't know.
Okay.
So I can assure you that it's a single array, but the cool thing is that, as we'll see in a second, you can have vector hold any type of array that you want. You can have a vector of ints, a vector of string. You can have vector of vectors if you wanted to. I've actually, in some of my code, I've had a triply nested vector. So a vector of vector of vectors of ints before. So, it's super easy to write down, and it's just super powerful. it's defined in something called the standard template library. We'll talk about this toward the end of the class. But what templates do as a sneak peek is they allow you to specialize the type of some internal members of a class. So you could say, well, I'm going to have an object which can hold any type at all, where you can pass an int or string or any type that you want, but I only want to write one version of the class so that it can specialize to all those different types. That's what a template does. And so because we want arrays to hold any type that we want, that's one reason why vector is defined in the standard template library. Okay, so how do you actually use this thing? So you have to include the vector header. You have to do that. But once you do that, you can just say vector of, now you have to use the angle brackets to say what type that you want on the inside. So if we want a vector of ints, we would say vector angle brackets with int on the inside. If we want to have a vector of doubles, that's easy enough to do also. You can actually specify the initial size if you wanted to. Yeah, so you can say that there are 24 ints in this vector here. And if we want to access individual elements of the vector, just use square brackets like you have done with arrays. So they look exactly the same like arrays, but they abstract all the details away, which is awesome.
Can you do multiple dimensions?
Exactly. You can do multiple dimensions too. So we can actually see this in action. So all we have to do to make our example from earlier work is include vector. And what I'm going to do is I'm going to have a vector of ints. I can't put the sizes right here. But what you could do is this. So suppose that there's a function to actually specify the sizes here. But one of the interesting things here is that each individual vector as the element can have its own different size. So instead of the 2D array that we had before, where each of the subarrays had size either 3 or 4, whichever way we did it, here the first vector could have size 100, and the next one could have 50, next one could have 2. We can make this as general as we want to. So what if we want to see in to the row and column here of this 2D vector? Well, what we can do is just say we're going to create an input variable. We're going to see in the input, but we need some way of accessing the corresponding vector and element of that vector in this 2D vector. So let's talk about that, not initialization. Okay, here. So if we want to actually put something into the vector, make it grow with more elements, then you use the pushback function. If I want to push on the front, what do you think the function name is? Push front. There are other functions like this, depending on the circumstances, but the vast majority of the time, you will use pushback or push front. So if whatever scores has before, whatever the values that are in scores, if I call scores.pushback of something, whatever it was before, the next element is the thing that we want to put into it. So if there's nothing in the scores vector so far, and we call pushback of 75, how many elements, first off, are in the vector now? 1, because that's the only thing we pushed back so far. And then the array contents are obviously just 75 in this case. But notice on the back end, it holds an actual array with an actual size. Whereas and it could have excess capacity compared to what we have put in so far. So if you want to know the number of things that we've actually put in so far, you call the size function. So if we put in 3 things, but the array itself has 10 things in it, size will tell you 3. And so it's much easier to work with this than normal arrays. So I'll talk more about this next time.